Hi there, thank you for joining me. We will be looking at very important topic on how to determine the percentage slope of your storm drainage. When you're laying that inlet pipe, you need to find the slope so that you have the flow of the drains or the water through the drains to the appropriate channel. So we'll be discussing that very shortly to support our storm drainage system for this class, right? So let's take a look at the design or the drawings we have here. This you will find this as part of your utility drawings. You have your structural numbers. So with this drawing, we have um, structural number 201 and 202. So how do we lay this pipe so we can have that flow, that percentage of slope to determine the flow of the drains, all right? So you look at this, we have the inlet A for structural drawing 101, inlet A for structural drawing 202, same as the invert for those structures, the B, and then we have the length where the pipe is going to be between these two inverts, right? So looking at the numbers we have here, the structural 201 has rain cover as 56.30. We have the invert A for the structural 201, which is 51.1, and then we have the invert B for structural 201 drawing, which is 51.00. Same things here for structural number 202. This design again is a utility design that will be part of your structural drawings, all right? So we're going to have same rain cover for 202, that is 56.12, and then we have the invert A and B, which represent 49.42 and 49.20. So how do we determine the percentage slope for this design? Looking at the formula here, it is what we need to determine the percentage slope for our laser pipes, which is going to go through, be using as a storm drainage, right? So the percentage slope formula is simply delta H divided by D multiplied by 100 because we are dealing with the percentage scores, right? So what is this delta H and D? Looking at the legend I have here, it details the change, that is the change between the slope is your delta here, and the H is the height for both inverts, right? And then the D simply is the distance, which I have 127 linear feet for this utility design. So we are going to be using these numbers to determine the change in height for our slope, right? So simply percentage slope will be equal to my invert A, which is 51.10, 51.10, and then we're going to be less than that from invert A for your structural drawing 202. So that is going to be again 49.42. All right. So pay attention here. We are dealing with the invert here. The invert A for structural number 201, we are using 51.10. And then we come to the invert A right here from structural 202, we are using 49.42. So that's what you see here. The idea here is that the difference, the D, which is the distance, is the difference between this inlet, right? The pipe, the laser pipe that we are going to be using for our storm drain. So it is not the outside length, it is the pipe length between these two structural drawings. So keep note on that. So when you pick your calculator, we are going to be less than that. Let me get that quick for you. 51.1 minus 49.42. My change in slope or change in height will be 1.68. And this 1.68 is going to be replacing the delta H here. And then we are going to be dividing. So we have 1.68 divided by the D, which is the distance, which is 127 here. 127 multiplied by 100. All right. So what will be my answer here? I divide 1.68 divided by 127 by initial answer is going to be 0.013 right there. So if I multiply that by 100, my answer is going to be 1.32. So 100, so 1.32 difference or change in height from inlet A with the structural drawing 201 and structural drawing 202 inlet A. So that is the slope or the number that we need to be able to effectively lay our laser pipe here in between the two structural design or draw elements to get a smooth flow for our drains when there's a rain off or whatever in our facility. That is very important. Pay attention to the numbers here. The slope 1.32. Is there something, if you're doing a layout or for your drain pipes to be able to construct it well, to have that smooth or the slope 1.32, there's something you need to think about again. You don't just pick this number straight away. You're going to be considering the direction of the pipe. How are you laying the direction of the pipe? Is it uphill or downhill? So if your supervisor, which this discussion is very important for you here, you need to consider the direction of the pipe. How are you going to lay it? So let's assume you have the pipe is sitting here. If you're laying it straight line, then you have 0. There is no change, anything added to it. So you're going to be using this 1.3 and perfect straight line. If you're going uphill, right, like that. So for instance, if you're laying your pipe from structural number 202 drawing up to 201, then you're going to be having a positive in addition to that. So you have your plus sign here. Again, if you're using your laser equipment to set up your layout, or you're using a survey instrument like Theodorite, so these plus minus are very important. So let's also, if you're going downhill, and the example here is that if you're laying your pipe or from 201 down to 202, so this is going to be a downhill operation, which is going to be negative sign here. So these are very important to keep the balance of the slope, so that when you finish laying your laser pipe for your storm drain project, it will not backflow to the footprint of your project. All right, so keep that in note very well. And I'm sure this example is very clear enough for us to be able to have the concept and start laying out our storm drains and helping our teams to properly determine the percentage slope so that we can have a perfect smooth flow of a rain of water into the footprint of our project. I hope this makes little sense to you and it's clear enough for you to implement it out there on your site design or utility layout project. Thank you very much.